Developers. Welcome back to my channel, and today we are going to solve longest substring of one repeating character. Now let's understand the question first, because if you see, the level is hard, but we will solve in a very simple way. I'll explain in a very simple way which you can understand. Now first, what is given, let's read it out. That we are given a zero index string s and also zero index query characters and of length k and query indices. So we have three arrays. One, we have two arrays and one string, and the two arrays are query characters, query indices. Now let's see what those arrays contains. Now we have total k queries. That means the size of query characters and query indices is k. Ith query updates the character in S at index query indices of I to the character. Okay, so we have two array, and in one array, what we are given is we are given two arrays. One is query characters, which will contain the characters like C, A, or anything what they will be given, and another will be query indices. Okay, and in indices it will be the indexes. Let's say 1, 4, 3. So what it is saying, this will be size k. Both will have the size k, and we are given what? We are given one string s. Of course, definitely the n will be, if n is the s dot length, my k will be always less than n. Okay. Now, what it is saying, sorry, let's see the constraint. What it is saying here, if my k is less than or the maximum length in k. Okay, no, my k is less than 10 raised to 5, but the number, that means this, sorry, query indexes should be less than, sorry for that, 10 raised to 5. Leave this then as of now. What I was trying to tell is basically each number in this query indices of this I will be less than my n, definitely, because what we have to do is for each query we have to replace the character from a string s for this index with this. For example, I have a, b, c, and d, and it is saying for the first query, okay, there are total k queries, k is 3 in this case. So for the first query, okay, for the first query we have to replace at which index? One index. This is at 1. From b to, I have to replace it to c, so it will be a, c, c, d. And then what is given in the question, if you read, it is given what we have to find. Till here we got, okay, what is the question. Now what we have to find, we have to return an array length of k where length of I is the length of longest substring of s consisting of only one repeating character after the ith query is performed. Okay, now after performing each query, what we have to do, we have to store, okay, we have to return an array. What will be the size of answer array? It will be definitely key. Okay, because every time we perform the this operation, then we have to check. Okay, so after performing this operation, what is my longest repeating, longest what repeating character length? Okay, so here longest repeating is cc is 2, so the answer is 2. Now for the 4, 0, 1, 2, 3, let's say one more. Okay, because I just want to make this example. So first was this. Now next my new string is this one. It's not like we will just replace this and check. My next new string is this. So at fourth position I have to replace this 0, 1, 2, 3, 4. At fourth I'll replace a, um sorry, I'll replace e with a. So I'll get a, c, c, d, a. But still I have this, so my answer will be again 2. Now in the next operation is third. Third we will replace with b. Instead let's do with c. Okay, let's do with c. So we get the answer at least subdivision. So this is 0, at third index we have D, we have to replace D with what? C. Now my new string will be C and A. What is the longest? Is 3. So my answer would be this. So now we understood the question. We have given two arrays. One is with the characters and another one is with the uh, another one is with the indexes. And then what we have to do for each query we have to replace the current character with the new given in that array for that index. And then we have to check the longest repeating, uh, you can say substring also, you can say, in which elements are same. Okay, don't get confused. I'm trying to say is we have to just longest repeating character length. Okay, now what will be my brute force approach? Okay, if I am thinking, okay, what I can do is I'll replace this, I'll build a new string like this. I got this new string, I'll do the same operation of checking the longest. Okay, so in that case what will happen? If you build this string, you'll use, let's say you are using the substring, that is one more operation. Okay, next is you will traverse with this. So let's say the size of this is q and this is n. Then you are traversing q times into what? Into n. Okay, so our time complexity will be this. If I do what? If I approach this by, I will, for every time I will replace this, I will build a new string and find the repetitive longest. How I will find the repetitive is basically I will just check the current element with the previous element. If it is same, we will increment the length, and if it is not same, we will check the max, and we will just length is equal to do the one, and same we'll do with the rest. Okay, if you want this solution also, let me know in the comment section. I'll create that also. But if you use that solution, you will get this q into n, and we are going to get TLE, because if you see the constraint, we have both 10 raised to 5 and 10 raised to 5. Okay, now next thing is we how we are going to optimize this. Okay, or let's see, like, think in different way, that what we are repeating. If you here see q, anyway we have to traverse q. Okay, but what we are repeating is this part, that every time after changing I am looking into whole string to get the what longest repeating length. What we call here is, what we call here, longest substring of s consisting of only one repeating. Okay, longest substring, I'll say from now, is to get that longest substring with the same character. We are checking each element of that string, character of that string for each query. So that's why we are getting TLE, and of course the constraints are high. So what we can think of, we can't ignore this. Okay, I mean, we anyway we have to traverse, so we have to think about this. So instead of traversing the whole string, can we do something like where the character is changed? Okay, we know the starting, we know the ending, somewhere in between. Okay, we know the starting, we know the ending of string, somewhere in between the character is changing, right? So why we need to check from here to here? Why can't we check somewhere here just? And how do you know that we have to check only this part? Okay, how do we know? So that's where it comes, what? Segmentary. Okay, what it does is, using this is a data structure like a binary tree or like a graph and everything. This is a data structure, segmentary, which will store what? Range data. What it will store? Range data. Okay, so for example, let's build a segment tree. What we will do, let's say you have the array, or simple array from 0 to 9 index. Okay, the size is 10. How we will build a segment tree is, it will be 0 to 9, then it's like 0 to what we can say 5, 6 to 9. If we do the half, it will be hmm, correct. And then here from 0 to let's say 2 and 3 to 5. I think I have made mistake. It should be 4 and it should be 5. Okay. And then here 0 to 2, 3 to 4. Then here 5, 6, 7. And this will be what? 8 and 9. 3, 4, 0, 1, 2, 5, 6, 7. Here it will be 0, 1, 2. Till when? Till we get the each element as separate element. Here we can say 5 and 6, 7, same 8, 9 and 0, 1. So segment tree is something like this. What we are doing, we are separating, or we can say we are dividing the current array by half. Again we are dividing it by half, 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 so that what it how it is helpful to us. Okay, now let's see. So if I know the maximum of this from this, okay, now what we have to do, we have to return the longest, that means maximum. Okay, now if I know the maximum of this, okay, so I can just use this 2 and get the maximum for this. This is the first thing. Okay, now leave that apart. What we were repeating, we were traversing each, right? Now what we can do, let's say my changed, okay, my index, this my index is somewhere between on the right side, so we will not even go on the left side. Why? Because the arrays, the string is not changing. So the length, we of course we have to keep track of the length, maximum length of that. But before that, just we have to think in which side it will go. Okay, so let's say my element is 6. Okay, my element is 6. So what I'll go, I'll from 0 to 9 I'll go this right side. From this I'll go here. From here I'll go this, and then finally I will change this position of 6th with what? With something which was there. Let's say with we need a here. These are just indexes, consider. We have to change with this a. Now if I'm changing with this a, I will change this here. Then what we will do is we will merge this. So again we will find the array, find the maximum, and we got the maximum here. Again we use both and find the maximum if in case it merge, and then finally we will use this and find the maximum. Okay, so again let's understand it properly. Maybe it might be little confusing. What I'm trying to say, let's say we have this a, b, 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 and it is what? It is into two halves, consider. Okay, now what I'm saying, let's say at index this, I'm replacing with a. So in that case, where I'm replacing only this part, so my new will be a, b, b. Now we have to merge these two. Initially my answer was 3, let's say. Okay, no initial answer. For this case I have to find the answer. So what we have to do is, this is the new one. Okay, now we have to merge these two. Okay, to get what? To get this string, right? Merging is just not clubbing those. What I'm trying to say is, here what was the longest? Longest was 3. Here longest was 3. Okay, now if I merge this, what will be my new longest? That's what we have to find here. Okay, now how we will do this is, we should maintain what? We should maintain the last element and first element of second. So let's say if I have two, left part and right part, I should have what? I should have last element of left and first element of right. So basically, if I'm saying this last, in a few cases, this can be this in. Let's say here I have a and a, again here I have a. These are just characters, okay? In that case, this will be my last, this will be my first. So basically I have to maintain the first and last element of each. Okay, first and last element I'm talking now. So if I know the last element and first element of this, I can say, okay, so these will merge. Okay, then I can consider of some new value for maximum. Okay, for new value of maximum. So in that case, what I need is I need the prefix of this. What is prefix? With the same element till when it is there. Let's say I had this a, okay, I'm merging these two. I should know the length of this. So instead of calculating every time, if I know the length of this, what I'll do, I should know the length of this also. This will be the suffix for the first element, this will be the prefix for the right. So I also should know the prefix size. Okay, I'll write somewhere. I should know the prefix, and also I should know the suffix. Okay, we got this, and finally we need the max. Okay, to get the max of that, and length we need. So that's it. This was the important part. So for each node, the node I'm explaining, for each node, if I have these values ready, and if I update this, okay, if I can build this with the segment tree with these values, I'm easily, see, first we have to build the segment tree, then we have to merge it. This is what we will get the segment tree normal. The next part is we will update. So when I'm updating, that time again I have to merge this. So while merging, I'll get the maximum value, and at the end I'll store at the root level. Okay, so first we'll build, merge, and update. So this in segment tree, these are the important one. Okay, so how for merge, how we derive the first and last prefix and suffix we need, and we need the length. Which case we need the length? We have to update, right? So when I am merging this AB and let's say AB, both are not same. Okay, so anyway, it doesn't mean I can't merge. We have to merge, just that we have to update our maximum or not, that we have to check. Okay, so if I have maximum here something else, if I have maximum something else, then I can just take the maximum of 2 if it is not merging, if it is sorry, if it is not colliding, if I say. Okay, if I have a here, if I have a here, then it can, um, what I can say, I'm not getting that word, but we can get a new answer. Okay, new maximum of this. So for that we need a last element, first element of both. We need the prefix and suffix, so that suffix of this part, prefix of this part. And to get that maximum, if that is same, then we can just make use of max is equal to max of what, uh, left dot suffix plus right dot prefix. Okay, maximum of this and max, then we can get, there is a possibility of new. Okay, for update, we understood the build, we understood the merge, and now we are going to understand update. How we are going to build, if I have explained, I think I explained the merge. So before that, how we are going to build this tree is just the same thing till we get the leaf node. Okay, for the leaf node, what will be my left, what will be my these values? First and last element will be same, prefix will be one, suffix will be one, length will be one, maximum will be one, and rest all we have to just calculate. What I should calculate for the left tree, for the right tree, and then I should merge it back, this merge. So in build we are going to use the merge, and for update, what we will do, we will update the element, and again we will merge it. So I will update that particular this, and at the end again I have to merge because we already updated. Okay, now, yeah, that's it. We will update, we just need these three methods. Now we'll start implementing, and then at the end for each we will just update this. Yeah, now let's start coding. If you have any doubts, Let me know in the comment section. Okay, now first what we need is we need a structure, right? So we first will use the class node. It should have what? It should have character, what, start and end. We discussed why we need. Then we need a int prefix, we need int suffix. What is this? The prefix and suffix sizes of same. And then we need the max, and then we need the length. Okay, we'll use a constructor where char start, char int, int prefix, int suffix, int max, and int length. And the start is equal to start, this dot int is equal to int, this dot prefix is equal to prefix, suffix is equal to suffix, this dot max is equal to max, length is equal to length. Okay, this is fine. This is, we created a structure. Now we have to write the build. Okay, now before that we need an array. Okay, node of I can say tree, just tree. We have to initialize it here. How will initialize? Int, oh sorry, node, what will be the size? 4 into n. Why? And let's take n before, because we are storing our tree into the single structure. Okay, single array. So in that case, what we use to, for the left, we use the 2 into that index. If I'm storing, my parent is at I, my child will be 2 into I, and 2 into I plus 1. This is you should know if you are solving the tree question or anything, if you're prepared. Now int n is equal to what? S dot length, 4 into n. Now first we should write what we have. How many methods? One is build, we need the node, we need the left, we need the right, and we need the string while building. Now next is merge. For merging, what we need? We need just left node and right node. Okay, we have to complete these methods. Now we have the update. What we need? We need the node, we need the left, we need the right. Other than this, we need the index at which we are going to change, and finally the character which we are going to change. Okay, these three methods. Perfect. Now before writing these three, let's write here code complete. Here what we are going to do is basically, for int I is equal to 0, I less than what, query characters dot length. It is a array, so just length I plus plus. I'm sorry, this is not character, it is, I'm sorry, this is not array. Okay, now my character C will be query characters dot caret I, which I want to change. What will be my index? Index will be query indices of I. Okay, now what we will do? We will update. Node will be my initially 1, 0, and minus 1. From this to this, what is my index? Index is this, and my character is C. So it will update. Now, what will be answer? We need an answer array. Sorry, is equal to new. What will be the size? Size will be query characters dot length. Now how we will say this answer? Answer of I, it will be equal to tree of I dot max. Why tree dot I, not tree dot I? Sorry, it should be tree of one dot max, because at the end we are storing the max at the root level, right? So that's why, and we will return our answer. Now let's start this. Why we are updating? Because of course we should we have the update method to update it. Now we will build. What will be the base condition of build? Okay, we are going to use the recursion. Base condition of build will be if my left is equal to right. That means we are at the leaf node, the each index. So in that case, what will be my tree of node? It will be new node. What is the start? Start will be the same. What we need a character. Character C is equal to what? S dot caret left. Okay, now what we'll do, in node what we have, start, end, prefix, suffix, max and end. Start and end will be same, that same character. Prefix and suffix sizes will be one, just one. Max will be one, size will be also one, and then we will return. This is my base case. Now for the current, to build it, I want to go on the left and right, and then I have to merge it. To go on the left and right, what I'll do, build. As I said, for the current node, what will be the child? 2 into node and 2 into n plus I was, sorry, 1. So here my it will be 2 into node, comma, left. Now we need to find the mid, right? To just separate it out. And mid is equal to left plus right by 2. Okay. Now here left, comma, mid will be my a right in that case for this part, and then same s. Now we will build the next half array. 2 into node plus 1, comma, mid plus 1 s. Okay, this we just built. Now what we have to do is we have to merge this both. So in that case what we will do is tree of node, it will be what? Merge both node. Both which node now? Tree of 2 into node, comma, tree of 2 into node plus 1. Okay, we have to merge this. That's it. For building, we are just using this left part, right part. At the end, it will come back and we have to merge. Now we have to write the merge logic. How we are going to merge these two nodes. Okay. Now let's write the merge. Okay, to merge this, first what we'll do, I'll take a int max. Max will be mat dot max of left dot max, comma, right dot max. Now how we are going to check? As I said, if my left dot what end, if it is equal to right dot start, then we can consider this as a possibility to like change the max. So mat dot max is equal to what? Left dot end and right dot start. That means left dot suffix plus right dot prefix. Left dot suffix plus right dot prefix, comma, max. We are just maximizing. Now we merged. After that we have to change the sub prefix and suffix of new node, right? And we need the length, updated length. So int suffix, let's say first int prefix will be, let's take left dot prefix and we will update it. How we are going to update? If my left dot prefix is same as length, that means there is a possibility that we can go, my prefix can increase. So if my left dot prefix is equal to left dot length, length is same, and Next is if my right left dot end is equal to right dot start, this condition, then my suffix prefix can expand. So my new prefix will be what? It will be left dot prefix is there plus right dot prefix. Yes, is equal to left dot prefix, sorry, plus right dot prefix. Okay, you can also write left dot length also. Now int suffix, let's calculate the suffix is equal to right dot suffix initially. Now if my uh, right dot suffix is equal to right dot length, if my right dot suffix is equal to right dot length, and same thing, okay, same thing, then suffix is equal to what? My new suffix will be right dot suffix plus what? This one, that means left dot suffix and right dot prefix, left dot suffix plus, or you can say right dot length. Now we got new prefix and suffix also, we have the max also, and length will be the sum. Now what we will do is, for merging we will return a node here, okay, and we will return what? Return new node, where we need what? First and last element. What will the first? Left dot start and right dot end. Now what will be my prefix? We just calculated prefix and suffix, and then we have max and we have length. What will be my new length? Length will be left dot length plus right dot length. Okay, that's it. Now this is my merge logic is done, build is done, we have to update it. Okay, to update, what we will do is, now for updation, it is the same, that we have to update that element, we have the character. Now what will the base condition? Definitely left is equal to, if my um yes, my left if is equal to right, then we got that element. And then what we will do is, tree of that node is equal to what? New node, we'll update with the new character. So my start will be c 1111. Why c? Because we have this, right? Now here we will return. Now if not, what I'll do, I have to check where I have to go, right? So again I'll calculate the mid will be my start plus end by 2. So if my index is less than or equal to mid, where I should go left, else I should go right. So to go left, what we will do is update for left 2 into node, right, for index, and then left comma mid comma index and c will be same. Else we will go on the right side. Right side means 2 into node plus 1, then here mid plus 1 comma right index and c. Consider we updated. After this we have updated. Now we have to merge it again, right? We have to merge after updation, we have to merge. Then what we will do, tree of that node, we have to merge for each. So I'll do what? Merge for tree of 2 into node and tree of 2 into node plus 1. I'm sorry, not here, inside only, node plus 1. That's it for the update. Let's run. So what we did, we built, merge and update. Okay, start, it is not able to find. I think I, sorry, it is left and right. Build, merge, and update. Merge will be used everywhere. Okay, max is null, at which we are getting this into max is equal to what we got. Cannot read field max because the parameter is null. Where we are calling the merge tree of node into this. Mm, this shouldn't be the case. Let's see if in update if we are doing something wrong. So, oh, we forgot that we have to build it, right? I forgot to build it only. So first we have to build it using what this node left, right, and s. So my node will be 1, left 0, and minus 1, and s. So when we build it, then only we'll have something to update, right? Yeah, see. So what we solved is basically why we use this solution is initially we were doing what we were checking the whole string for each query. Now what we are doing, we are only checking that path, and that's how we solve this question. If you have any question, let me know in the comment section. I'll be always there to answer those. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.